Yes, I'm Jan Durant. My company is JLMA Engineering. We've been in George for 26 years for steel fabricating, all kinds from structural steel work, all housing, things like that. And so we done all the structural steel for Andre on his house. The fabricating, the design, the design drawings, the stock drawings, and the erection.
Fantastic. Andre, do you want to let us know who you are, what your role was?
Okay, I'm wearing two hats with this project. The first is that I'm a shareholder in the property. And the second is that the shareholders decided to appoint me, fortunately, as the architect for this project. So that's how it came into being.
Okay, fantastic. So I've got a couple of general questions. Yes, go for it.
Denise with me is the project engineer, and I'll let him introduce himself as well. He's using the same premises as I am, so he'll just move into the camera shot.
Okay, super. Magic.
Hi there, I'm Dave Hall, structural civil engineer. Been in 50% of my time in construction and 50% of my time in design, and live in Knysna now, and try and get involved in most of the projects in Knysna if I can, both from the construction if I can and also from the design work. So I'll have a little chat about the structural side.
Okay, super. So I think you can stay there, because we're going to start with the questions that relate to structural, and then we'll go through the architectural questions after that. So structural and fabrication. So Jan, if you want to chime in on some of the answers, that'll be great. And then if the judges do have any questions as we go along, then they'll also ask. So structurally, can you just give us a brief description of what the actual structural framing entails? I don't know who wants to go first there, engineer.
Okay, I'll just kind of introduce from a overall point of view, from a structural point of view. A lot of the description, the architect is also included in his presentation. So a lot of it would be duplicated, with Andre knowing the background and also being involved with what he wanted and what his client wanted. But initially, I worked very closely with both Andre and Jan in getting to the stage of getting this particular structure built. The initial framing, beam sizing, and aesthetics from Andre's side had to look good, had to show a lot of steel. That was his primary importance. When we first initially started, we were looking at beam size of 254 146, and it was either 31 kilogram a meter run for most of the beams, except for the front section, which had more loading with regards to a cantilever and also spanned a little bit further. And having the standard size beam throughout the structure, Andre's requirements were met. This satisfied myself from the initial prelim designs, combined with the concrete. It was so from that point of view, we got started, and we had to very closely look at the geotechnical situation, because this played a very important part. This whole house is built on a dune sand, dune right close to the sea, collapsible dune sand. And added to that was a major problem of the well-known dune rat in this particular area. The design then had to be looked at with a composite design, including the concrete slabs tied into the beams, okay, with shear connectors, and also putting some negative steel over the top of the beams to make it continuous, so that we could then basically span further and get less settlement for larger larger for a smaller beam. This allowed the moment resistance of the beam to be increased for the steel, and then also the settlement in the concrete structure to be reduced, and also allowed less settlement. Okay. Once again, we enjoyed the cost benefit of using the smaller beam size throughout. But when we got to the front section, you'll see of the building, the span then went to basically 14 meters, and we kind of then used the same structure, same beam size, and formed a lattice beam arrangement running across the front, which also carried the cantilever off this lattice beam. This design allowed us to span the distances. The only hiccup we had at the end was that we needed a damper on the steel cantilever to kind of stop a bit of the spring, which it was there, but it wasn't a lot. But the Andre wanted to try and nullify it. So by doing that, we kind of put in a damper, hid it behind the fireplace, so which also then made a tremendous difference in stopping any spring in that particular cantilever section. Overall, the fabrication went according to plan. One or two holes, of course, were always out of position, which always happens in position on projects to this type of detail. Most of our connectors were all 8mm plate with 16mm diameter bolts. Okay, these bolts were always drilled a little bit, holes were drilled a bit bigger to allow for the galvanizing, which we need down here at the coast, a very important actual aspect of steel. The other important thing is a lot of our splice bars into the cantilever, which were connected to the steel, the structural steel, was actually done on site and then basically protected, and this was then covered up with the structure, with the concrete, which was then poured. The concrete side of it, we used the ribbon block system, which also tied in very nicely with regards to fabrication of taking each of the ribs into the flanges of each of the beams. And then also this worked incredibly well. And one or two areas where we had to make up certain areas, this would then have been cast in situ concrete, where the ribbon block was too finicky for that particular area. Overall, the achievements, we had a 20% saving in the steel through changing the design to a composite design. Very little deflection. I think it's about a 5mm deflection the last time we looked at it, and the unique structure has paid off with regards to getting the look of showing that steel was very much present and keeping this whole structure up. That's all from my side.
Yes.
Could I ask a question? You spoke about the damper. What did you actually use to damp it?
We had two choices. We could either have loaded the cantilever with some more dead load,
yeah,
or we could have then put in a vertical support behind the fireplace, which was acceptable.
Yeah.
So we went for putting the vertical support in behind.
So you tied it back to the roof or down to the ground.
Correct, and that kind of then there's absolutely no more. Movement.
It's surprising how little damping you actually do need.
Yeah, it's quite incredible. When you do your design, I'm still trying to find someone who would actually, or some form of text that would tell me what my damping is going to require or what I'm going to need. If I had have used the higher sections, the bigger sections of the steel, I would have probably not needed it. But having a 150,000 rand saving in the steel cost, that small little bit of damping paid for itself.
Take the advice of one of the really well-known structural designers in the mining plant equipment who became chief structural engineer for an international mining plant design company. And his attitude to structures with vibrating screens, which needed damping, was let's start the screen up, see where the thing is vibrating, and put in a few extra knee stays and bits and pieces there and then, and he solved the problem that way.
I think that was our kind of attitude here as well. You know, we didn't really know what we required. I did a steel bridge previously, and we did a very simpler, but we loaded it with more dead load. We hung concrete blocks underneath it, but you couldn't hang concrete blocks underneath this particular one.
So you could have brought big flower pots in.
Yes, we were thinking of that, but the loading would have had to be massive pots for the dead load. As I say, one simple vertical column just solved all the problems.
So,
Sorry, Andre.
Yeah.
One question. How did you achieve composite behavior in the slab? Because the picture is not zoomed in enough to see studs or anything on there.
All right. What we did is, first of all, with the bigger sections, we weren't going to have a composite design. The slab was going to fit right into the 254 beam size. Then we went to 203. Then we went with 200 in between the flanges, and then a 50 millimeter screed over the top. Okay, and then we combined with some studs. We had studs, and then we also tied it in with some negative bending steel over the top. Okay, to make the concrete beams continuous. So with a combination of negative steel and some studs, not at very close centers, but it was a partial. Very much a partial composite design. It wasn't a fully composite design. I didn't take all the concrete in the design as my compressive steel. I only took partial of it, which I didn't need as much, and it still gave me the results that I wanted. But what I also found with having the steel and that 50 millimeter engineered screed over the top with the negative bending steel, it allowed us to also get far less deflection in the concrete component.
So the studs are on the webs of those I-beams?
No, on the flanges on top. Okay, on the flanges.
In the 50 millimeters?
Yes, and then also you've got the steel going across that as well. Yeah, but then the steel also tied it in as well. In a way that was difficult to try and calculate, but it really did the effect as well.
Great.
And you said these were ribbon block slabs, but is that polystyrene or in the pictures, or is it actually
hollow block? Yeah, I use a 130 hollow block basically, and that also lightens the structure as well considerably. So you're taking 100 millimeters of the concrete weight off that as well.
I saw that you guys used the hollow blocks on the floor. Is that polystyrene?
No, everything's suspended. The first floor is also suspended, and the second floor. So basically everything came up out of the ground. There's nothing sitting on the floor except for the garage in the cut area.
What did you use on that lower floor? Is that polystyrene block, or is it still the ribbon block?
No, it's still a ribbon block.
Still the ribbon, okay.
Okay. Any more questions, or can we move on to the fabrication and erection questions for Jan?
I just got a question. Did you consider using steel columns at the bottom of the structure?
We have got steel columns coming up. There's 32 steel columns. No, sorry. No, we were going to use steel columns, okay, but we then changed to concrete being a lot cheaper than coming up with the steel column. We would have had to use 133s by 133s, but by using a 200 diameter concrete column coming up, reinforced with 4x16s, it was fine. It was also quite a lot cheaper as well. But then that was then connected to the steel frame.
Right, I understand. Did you consider using a tubular steel column, a tubular steel section for that?
No, we didn't. No, we didn't, because the former we used was ordinary fiber cement former, which also being here at the coast, we also thought that would be more advantageous.
Thank you.
Great. Jan, can you tell us a little bit about the actual fabrication and erection process in terms of...
Sorry, Denise.
Yes, can you hear me? Can you hear me?
I can hear. Are you wanting me to carry on?
Yeah.
Can you hear me?
Jan, can you tell us about the fabrication and erection process in terms of complexity and difficulty? Anything that you think the judges should be aware of?
I think, look, the biggest thing, obviously, as Dave said, with a structure like this, is it had to be architecturally acceptable visually, because of all the exposed stuff. So the big thing was all the connections that we had to look at, what would work from an engineering perspective, and what Andre wanted to see from his side. And then the other thing we had to take into consideration was most of the infill of the steel was with glass panels, with aluminium frames, and there couldn't be any... he wanted a clean finish between that. So I think the complexity of the structure was really in the connections, and also where it came to leave it, we had to look at those connections and that as well, which Dave and myself had to design. Had to design on, and then Andre had to say yes, that's what he wants. He's happy with that look or not. So I think the complexity was in the connections, and then obviously the fabricating drawings was another thing that took quite a bit of time. Looking at each detail, and that was done by my guy who does all my structural drawings on advanced steel, and I think he did a pretty good job. As Dave said, with the complexity of all the members in that, there is always one or two holes that don't work as they should, but that was all sorted out. The fabrication was pretty straightforward. Once you've got the right drawings and you've got the right information, the fabrication wasn't an issue at all. The only other issue was the erecting, because of the location of it and the erection time. To get the only other way we could actually erect it was with a crane, and the crane that we needed to get to that reach would be far too expensive. So we opted for hand erection, which took considerably longer than we had hoped it would, but just because of the location of the structure, it was that was our biggest challenge, was on the erection side. I think that's about it.
For a question for Jan.
Yeah.
I don't know if you did this part of the erection, but on that first floor, how did you prop those slabs, ribbon blocks on sand?
No, look, I didn't do any of the structural work. Mine was just the concrete structure. Mine was just the steel structure. So I went in, I put in the steel structure, and then I walked away.
Okay.
You want me to answer
and that was actually pretty straightforward. I think as Dave said before, those concrete columns that they supplied us in their position was I think a very good idea, because our structure chemical anchored into those into the concrete bases, so we didn't have to worry about exact positions of those concrete pylons either, because we could lay our steel on top of it, get everything square and in place, and then we would fix down into the concrete columns.
Okay, great. Either structural engineer or fabricator can answer this question. How would you say that this particular project really demonstrates the benefit of steel as a material?
Dave?
Yeah, if I could Okay, what's actually happened is that both Andre and myself have kind of answered this because it comes up in the architect's thing as well. But there's a lot more flexibility in structural steel with regards to the unknown of our dune rats burrowing again, coming and destroying everything underneath it. Hopefully they don't go deeper than 1.5 meters, which is what the research has shown, that they don't go deeper than 1.5. It took us a long time to research these dune rats. So if there was any future settlement, then structural steel would be more flexible in taking up any differential settlement if it would have, if it does take place. That was my side from a structural point that I thought was a great idea from a structural steel point of view. Okay, much longer spans were achieved for members, which was in proportion to the structure. If I had gone concrete, of course, my structural depths of the concrete would have been a lot far greater than what it would have been for the steel. It gave a form of an airy floating design with regards to what I also thought was super. The prefabrication was, once you got that, we on top of that, it really helped the timing and the ease of design. Okay. Lightweight with regards to being able to handle it ourselves. As Jan said, we actually couldn't afford a crane, and also getting the crane onto site, so we had to manhandle. And with block and tackle and that, we actually did manage to erect substantial beams. Okay, and mention the speed and ease of erection. As I say, one or two holes in the wrong position, but after that, it really worked like clockwork and went incredibly well. Cost effectiveness, I've sat with Andre afterwards, and basically, if I'd have built a brick and mortar house here, the costs would have been very, very similar. We're probably looking at all in around about 10 grand a square meter at the end of the day for this particular structure, which ties in with what the building costs here in Nassau is. Plus, I think you're getting the added value of actually seeing the steel. I work with a lot of architects, and a lot of their steel members that they put into the structure aren't designed to carry anything. They're more for perception and curb appeal and look. Whereas here you've actually got it working for you, and also giving you that effect. And it's very durable. Steel incredibly durable if it's galvanized here and protected. That's why also very important to have galvanized all the holes for the bolts, and also it's a resilient component of the whole structure, tied in very nicely with the framing of the timber and the actual concrete. So it works very well with the timber and with the concrete.